Module 2, Health and Safety. Here are some definitions. Hazardous material. A hazardous material is a substance or material that is capable of posing an unreasonable risk to health, safety, and environment. A hazardous substance is defined as any substance regulated by the EPA or Environmental Protection Agency as posing a threat to waterways and the environment when released. Hazardous waste. Hazardous waste is any material subject to the Uniform Hazardous Waste Manifest requirements of the EPA. There are three areas of concern when dealing with hazardous materials: flammability, reactivity, and toxicity. Factors that affect the levels of potential harm. First would be the rate of release, or how fast. Second, size of dispersion pattern. And third, the toxicity of the material. There are 4 routes of exposure: ingestion, inhalation, skin absorption, and injection. Exposure versus effect. An acute exposure is a single contact with the material, whereas a chronic exposure is repetitive exposure over a long period of time. Effect. Immediate effect. It's apparent as soon as you are exposed, versus a delayed effect, which is as apparent as much as several years later. Definition of vapor density would be gases with vapor density greater than 1 are typically heavier than air, so they would sink to the ground. Specific gravity. Less than 1, something would float in the water. Greater than 1, it would sink in the water. Obviously, sometimes things can also be soluble in the water. Flammable limits. The lower explosive limit, known as the LEL, is the lowest concentration of product in air that will burn. Gasoline has a LEL of 1.4. An upper explosive limit, or UEL, is the highest concentration of the product in air that will burn. Gasoline has a UEL of 7.4%. Possible ignition sources: heated surfaces, frictional heat, radiant heat, spontaneous ignition, lightning, open flames, smoking materials, cutting and welding operations, static electricity, electric and mechanical sparks, and heat-producing chemical reactions. Corrosive substances are acids or bases. They are substances that will burn or otherwise damage body tissue, metals, plastics, or other materials as a result of contact. The pH scale is from 1 to 14. Acids are the lower pH scale, whereas something neutral like water is 7, and bases are from 7 and up to 14. An example of something 14, high pH, would be lye. pH can be defined as the numerical measure of the material's acidity or alkalinity. Common acids would be hydrochloric acid, hydrofluoric acid, nitric acid, phosphoric acid, and chromic acid. Common bases are sodium hydroxide, sodium hypochlorite, aqueous ammonia, potassium hydroxide, and ammonium hydroxide. Toxicity. The degree of toxicity will vary with different toxic materials, the amount of physical exposure, and the amount of exposure over time. It's usually expressed in LD50 or LC50. The lower the LD or LC dose, the more toxic the substance. Radiation. Time, distance, and shielding is important with respect to radiation. The less time, the less the dose. The greater the distance, the less the dose. The better the shielding, the less the dose. With shielding, you're shielding yourself from alpha, beta, and gamma particles. Paper can stop alpha particles. Aluminum can stop beta particles. Lead can stop all particles. However, some gamma particles may go through. A confined space is defined as an area which, by design, has limited openings for entry and exit, unfavorable natural ventilation, and could contain a hazardous atmosphere, and is not intended for continuous employee occupation. Personal protective equipment. There are 4 levels of personal protective equipment: A, B, C, and D. Chemical intrusion of PPE. We look for degradation or the loss of the beneficial physical properties caused by exposure and/or time. Penetration would be the flow of hazardous chemicals through the pores, the seams, the zippers, and the materials. And permeation. Hazardous materials move through protective clothing on a molecular level.